Welcome you all students. In this video lecture, I will teach you one of the questions from the centroid. Locate the centroid for the L section as shown in figure. So this is the given figure. For this, we need to specify the centroid, right? So to find centroid. So centroid here x bar and y bar, we need to find it. We have to see the answer for x bar and y bar. Okay. So let's get into the solution part. So first step to identify the centroid should be you may get the composite sections. Okay, here it is L section. First step is you need to divide the given section into simple section. Okay, simple calculated section. So we have some basic formulas, right, for the rectangle, square, then right angle triangle, then equilateral triangle, circle, semicircle, quadrant, right? So we need to just break down or divide the given component into a simple section. Okay, fine. So here just I going to draw the diagram. Let me draw the diagram first. So this is how the L section is, and the width of the L section, which is given 10, and length has been given as 6 centimeter, here as well centimeter, and the thickness of this rib, which is given 2 centimeter. Okay, right. So first thing, before dividing it, we must take this diagram into the coordinates, xy coordinate. So I just going to left extreme this as a point, so I just going to take this as O point, and with respect to that, just I going to bottommost, I just going to draw a horizontal line which is x-axis, and with respect to this left extreme part, I just going to have a vertical line which is y-axis. So just I have taken this into the coordinate x and y, right? Then try to break down the L section. I just going to break down this L section just like this, okay, and I just going to consider this as one part and this as a second part. Okay, this is the one part and this is the another part, two parts, right? Both are a rectangle. Okay, so after dividing into a simple section, the next step should be for each and every individual part we need to find the self centroid x1 y1 and the area. Okay, similarly the next for the next next component, again we need to find the self centroid and the area, right? So first I going to begin with the first component 1. So 1, which is a rectangle. Okay, fine. So that particular part, take it to the coordinate. So I just going to draw the xy coordinate first. Where it is located in the xy coordinate, just you bring it here. So this is the exact component, right? So I just going to take this. So its length is 6 centimeter and its width is 2 centimeter. This is how. So for this we need to find the centroids. C. This x distance, here it is x1 since it is a 2 component. So here this distance is a y1. Can you got it? This is the thing we're going to find. x1 from this to this O to this particular things. What is the formula for rectangle? Rectangle centroid not to specify its length divided by 2, right? So here b divided by 2, so that it will be 6. 6, b is a 6 centimeter, 6 divided by 2 we get 3 centimeter. What about y? y1, specify the y1, O2 this distance, centroid. What about the formula? Formula for the centroid in y direction, y axis, it's breadth divided by 2, right? That means h divided by 2 I have given in the formula. So here the h is 2, this is the width is 2, so 2 divided by 2 we get 1 centimeter. Afterwards, for this particular rectangle, first rectangle, we need to find the area which is A1. I am going to denote it as small letter A1. What about the formula for the area? Length into breadth is for the rectangle, length into breadth, BH. So B is 6, and H is 2. What's the answer? 6 into 2 we get 12. What about the unit? Here concern, since it is centimeter, we have taken all the things in centimeter, and here b into h, so centimeter, so the area will be centimeter square. Okay, just keep it in your mind. For the area unit, SI unit is centimeter square. And move to the next part or next component. The second component also a rectangle. The second component also a rectangle. Okay, let it be. And just have a diagram. X, Y coordinate. This is O. And where this second part or second component is being located, just keep there. So here the component is something like this, right? Something like this. This is the second component. And here it is very important, we need to take the measurement how ahead from the x axis. Okay, this part, this component is how ahead or how far from this x axis. So here this component 2 is ahead with 2 centimeter. So just here note it down, so it will be easier for calculation, 2 centimeter. Okay, and then what about this particular length? This particular length, the entire length of this L is 10 centimeter. Then what about this distance, this end to this second component length? 10 minus 2, we get that particular thing, right? So this distance is 8 centimeter. So please try to understand it. This component is 8 centimeter. Entire length is given in the question, but we need up to this. So it is 8 centimeter. And this thickness already it is given. The entire thickness is 2 centimeter. Here it is given, not mentioned. So it says the entire thickness of the L is 2 centimeter. So which is 2 centimeter. Okay, this width. Fine. So now we need to plot the centroid for this particular rectangle, the second component. So if it is a centroid, approximately from this ON to this measurement we need to find it, which is x2, and this y distance we need to find from O. That is very important. We are going to find from O, which is y2. Okay, this two we need to find. So first x1, it's a rectangle, so the similar formula, b divided by 2 x1. So here you see the component is from the end of O, right? So just a self or the centroid alone. So here b divided by 2, length divided by 2. What is the length of this object? 2 centimeter. Length is 2 centimeter. So 2 divided by 2, we get 1 centimeter, right? And what about the y1? y1, see, we are going to find the self-centroid, right? So from where we are going to plot, that is very important. From O to this y2 distance, right? from O to this centroid C in Y direction we are going to find it. Okay. So we know this centroid, the component formula, that means the centroid for a rectangle up to this which is h divided by 2, am I right? Up to this the component is h divided by 2. We are going to specify the y1 y2 from O to this particular C. So the formula can be written here up to this component distance is 2, so 2 plus 2 plus h divided by 2. Okay, the formula for the rectangle is h divided by 2 in y, right? But the thing is the component is some far from this x axis, am I right? From x axis. So we specify the y2 from o point to this C. So we just added this 2 plus itself centroid. So 2 plus h divided by 2. So here 2 plus h, what is the breadth, which is 8 divided by 2, so it will be 6 centimeter. We get this in 6 centimeter. What is next after finding x2 and y2? It's not x1 y1, it's a mistake. X2 y2, second component, right? So here we just going to find out the area a2. It's a rectangle, so the similar formula, length into breadth. So b is 2, length is 2, and its width or breadth is 8. So here we get 16 centimeter square. This is A2. Okay, fine. So here just we have found for each and every divided component, simple component, we have plotted the x1 y1, h2 y2 and the area for each components. Our task is, for this components we need to plot the centroid. So what I just going to do is, just I going to combine all the two components, okay, in order to specify the x1, x and y for this particular L section, okay, so that the formula will become, the formula will be centroid for x bar. Here in total we call it as x bar, and sum of first moment of the area about y axis divided by total area. Okay, always x distance we will be specifying from the y axis to the particular c distance. For y measurement we specify from x to, that means the x axis to the particular distance. So here for the centroid x bar, sum of first moment of inertia about y axis divided by total area, right? So similarly for y bar it will be sum of first moment of area about x axis divided by total area. Okay, so this formula can be simplified as sum of first moment of area. So moment in the sense we know it is nothing but force into x perpendicular distance, right? So here the moment of area, so instead of force here it is area, right? So a1 x1 plus a2 x2, sum of first moment of area about y axis. So all the x1 y2 plus a1 and a2 will be considered. So if you have two components, we will be having two the terms. So if you have more than 2 or 3 or 4, regarding that it will be what increasing. The formula will be increasing if we have 3 component plus a3 into x3, something like that it will be. So divided by total area. Total area in the sense a1 plus a2, all the areas must be added together. So here what will happen, try to specify, try to uh, update it. Just a1 is 12 into x1 is 3 plus, right, a2 is 16 into x2, so x2 is 1, okay, divided by, add all the area, 12 plus 16, 12 plus 16. Just do the calculation. I hope you will get, when you are dividing, you will get the answer as 1.837 centimeter. X bar is 1.837 centimeter. Similarly, calculate it for y bar. Y bar. Sum of first moment of the area about, here it is y axis, not y axis, here it is x axis. For y it's x axis. So here total area, okay. So here the formula will be a1 y1 plus a2 y2, okay. Here a1 x1 plus a2 x2, here a1 y1 plus a2 y2 divided by a1 plus a2, the total area. So we get the formula, when you update it, we get a1 is a 12 into y1 is 1 centimeter plus a2 it is 16 into y2 which is 6 centimeter divided by 12 plus 16. Here we get the answer for y bar as 3.857 centimeter, okay. So after that you need to specify the result. So here I just going to show the result. Just I don't have space, I just going to take the result. After completing the x bar and y bar, below that you need to make the title result. How will you plot it? So take the diagram first. So this is how the diagram is. It is x axis and it is y axis and this is O. See here x bar is 1.837. So this thickness is 2 centimeter, right? So 1 in the sense in between this, that should be. So in between that I just going to take the axis line. So this is the x bar, this is the x bar. And what about the y bar? Y bar is 3.8. So this thickness is 2, more than this, that line should be. So somewhat ahead I just going to plot it down. So this distance is y, just y bar, okay. So here you can write 3.857 centimeter. So here in the x bar it is equal to 1.837 centimeter. So in a neat manner you need to specify the things. So O2 this particular thing is x bar and O2 this particular thing is what, y bar. So this point is a centroid, so specify with C, okay. So I hope you understood. Whenever you are having any kind of composite section, first thing is you need to bring it into the coordinate and just divide it into a simple component. And afterwards, each component individually we need to specify the centroid x1 y1. After that, just combine it with a formula x bar is equal to sum of first moment of area about y axis divided by total area, and for the y bar sum of first moment of area about x axis divided by total area. So by that x bar and y bar, the magnitude, how much is the amount, the measurement can be taken from the O with respect to O. Okay, so afterwards you can specify the result with a diagram. Okay, I hope you understood how we need to work and how we need to specify the x bar and y bar and denote the centroid. Thank you so much.